Hi, my name is Mike, and I'm here to help you understand an easy way to look at how to solve a two-step equation. And we're also going to talk about inequality statements and inequality equations, statements with inequalities instead of an equal sign. And we will also talk about why you have to change the greater than or less than symbol when you multiply or divide by a negative number. But first, the way that I like to share this is thinking about an equation as having multiple layers. So I like to draw the the analogy to Shrek. Shrek said, you know, ogres have layers, onions have layers, and of course Donkey didn't get it because he likes parfaits. But if you look at an equation, you will kind of see in a two-step equation, you're trying to isolate the variable. So let's take a look at that. And what you want to do is, if you're thinking of this as layers, you have a problem here. So this would be 3 times the difference of x and 6. So 3 times x minus 6 is equal to 6. So 3 times some number minus 6 is equal to 6. So there's two things that are going on with this variable. You have this variable is subtracting a 6, and the entire solution here is being multiplied by 3. So if you think about this with the onion metaphor, you could say, well, here is the center of your onion. This is what you want to, at the bottom, you want x is equal to something over here. You want to isolate this variable. Isolate means get it all by itself. You want to get this by itself. There's two things that you have to get rid of. You have to get rid of the minus 6, and you have to get rid of the times 3. Now, normally when we're solving an equation and we're just evaluating it to find out what an equation does, we use Pemdas. So we go parentheses and exponents, and then we multiply, divide, and we add and subtract in that order from top to bottom. When you are finding a variable, you're doing the opposite. You're going to basically untie the knot, and we're going to, in this case, peel the onion. So if this is your middle, then this is kind of a second layer, the minus 6. The third layer is that times 3. So when you peel an onion, you have to start with the outside layer, right? You can't start at the middle. You got to peel the onion outside. So you're going to work from the farthest away from the variable. You're going to work your way backwards. So if we go, I'm just going to get rid of this. And we're going to do reverse PEMDAS. So the first thing that we're going to do is, instead of subtraction going last, we're going to, let's get rid of that. We're going to get rid of the times 3. So how do you get rid of times 3? Well, reverse order of operations. So the opposite of times 3 is divide by 3. So you're going to divide both sides by 3. And that is going to give you over here, the 3's are going to reduce. 3 over 3 is 1. So over here now you've got x minus 6, and 6 divided by 3 is 2. Now we need to get rid of minus 6. So again, we do the opposite, one step at a time. The opposite of minus 6 is plus 6. So we're going to do that on both sides of the equation. X minus 6 plus 6 is just an x, and 2 plus 6 is 8. We have our answer. Like you should always check. You should always check. So if we put an 8 in place of the x, and we're going to say, is this true? Is 8 minus 6, which is 2, times 3 equal to 6? Yes, it is. That's a good solution. Easy enough. So let's move on. Obviously, now I have some problems here that I work on with my adult learners. And there are some that are going to look a lot more complicated than others. So we're going to just pick one of these, and we're going to do the same thing. We're going to peel the onion. I think what we're going to do here is we're going to take 11. So the first thing you should do is write it down on your work paper. And then you should pause the video and see what you can do with this. Okay, so I'll give you a few seconds. Pause the video. Give it a shot. try to work from the outside in and see what you can come up with. Okay, hopefully you tried that. So again, we're looking at, this is where we want to end up. So the next layer here would be that times 2. The layer after that is going to be that minus 10. And then you have 5 over 2. So that's really its own layer right there. And then you have one final layer right here with the plus 14. So this onion has a lot of layers. And remember, if you're not sure, you're going backwards from PEMDAS. So you're going to take care of addition and subtraction first, then multiplication and division, then exponents, then parentheses. All right, so let's rewind a little bit here. So the very first thing, the outside here is this plus 14. So we are going to get rid of plus 14. And we're going to get rid of plus 14 by going minus 14. So we subtract 14 from both sides. Okay, no problem. These are going to cancel out and become 0. And now you've got 5 times 2 times some number minus 10 divided by 2 equals 19 minus 14 is 5. Okay, so this is our next layer. Okay, it's the farthest thing away from the variable. And the easiest way to deal with this, instead of dividing by 5 and then multiplying by 2, you can just invert this and put a 2 on the numerator side and a 5 on the denominator side. That way the 5s cancel and the 2s cancel and it's gone. Over here, you've got to take it times 2 over 5. So these cancel, so we've got 2x minus 10 equals 5 times 2 is 10. 10 divided by 5 is 2. You can see that because those are going to cancel out. Next step. Now we're inside the parentheses. We can drop the parentheses. We don't need them anymore. We're going to add 10 for both sides. This is going to cancel out. You're going to have 2x equals 12. We're just slowly getting there, one step at a time. Last step, divide by 2, divide by 2. These cancel out. X is equal to 6. We're going to take that 6, we're going to put it back up here, and then we're going to follow the PEMDAS order. 2 times 6 is 12. 12 minus 10 is 2. 5 times 2 is 10. 10 divided by 2. Oh, let's try this again. Yeah, 10 divided by 2. Oh boy, I think I got it wrong. And this happens sometimes, so you gotta be careful. Maybe I should be writing it out, but let's see if I can do it. So we have an answer of 6 down here. Well, that's, you know what? That's the way real math works. It's not perfect, and I don't edit, so let's just clear this up a little bit. Let's check this, make sure we're good. So 2 times 6 is 12. 12 minus 10 is 2. 5 times 2. 5 times 2 is 10. 10 divided by 2 is 5. 5 plus 14 is 19. Okay, cool. So it does work. We did do it right. I just wasn't checking it carefully because I was doing 10 divided by 2 is not 2. 10 divided by 2 is 5. 5 plus 14 is 19. Okay, so every one of these questions would have a different interesting thing that you'd have to figure out. Some of them are going to have square roots or squares. Some of them have more fractions. Some of them have positive and negative numbers. Some of them you have to combine like terms before you do anything else. All right, so there's one more thing that I want to talk about, and that is the idea of when you're solving an inequality. The big thing with this, and you probably heard this a bunch of times, is if you multiply or divide both sides of an inequality by a negative number, you have to reverse the inequality. So greater than becomes less than, or greater than, less than, or equal to would be greater than and equal to, something like that. So just taking a look at a problem, hey, we're starting here on July 11th, good deal. Taking a look at this problem, you have, let's make sure we get one where we do have to reduce it. Now let's just start with the first one and see what happens. Okay, so you're starting off with this. Now you're gonna, again, isolate that. So you're going to add 7 to both sides. Now, do you switch anything? No, because you're not multiplying or dividing by a negative number. So you have 3x is greater than 5 plus 7 is 12. And then dividing by 3 and dividing by 3 is going to cancel out, and x is going to be greater than 4. You do that exactly the same way you would do any. If it was an equal sign, you would do it the same way. So let's try another one and just see what happens here. So let's try number 7. Negative 4 times x plus 2 is less than 24. So this number can't be real big here. Let's take a look at it though. One rule that people get stuck with is if you're trying to do this, you have some choices. We could divide both sides by negative 4. I like to go ahead and just distribute this and do it that way. So negative 4 times x is negative 4x, and negative 4 times 2 is negative 8, is less than 24. Now we can add 8 to both sides. We're not flipping the sign here because we're adding. No big deal. Those cancel. Negative 4 times x is less than 32 now. So here's where it comes into play that we're going to divide by a negative number. So if we divide by negative 4 and divide by negative 4, these are going to cancel out, and x is now going to be greater than 32 divided by negative 4, which is negative 8. If we take our negative 8 and we put it back up in here, and we run that question, negative 4 times negative 8 plus 2 has to be less than 24. This still has to be true. So here's where we check. Negative 8 plus 2 is negative 8 plus 2 is negative 6. Is less than 24. Negative 4 times negative 6 is 24, is less than 24. Well, we know that's not true, right? So that's why x has to be greater than negative 8. We need a number greater than negative 8. So if we go back and we put in a number greater than negative 8, negative 4 times, let's say negative 9, plus 2 is less than 24. Now, our answer said x has to be greater than negative, oh boy, did I ever just make a mistake. Negative 9 is not greater than negative 8. This is the problem with talking at the same time. Talking and mathing at the same time doesn't go. How about negative 7? Negative 7 is greater than negative 8 plus 2. Okay, now we've got a number greater than negative 8. Negative 4 times negative 7 plus 2. Negative 7 plus 2 is negative 5. Negative 4 times negative 5. Will that be less than 24? Well, negative 4 times 5 is 20. Negative times negative is positive. 20 is less than 24. And we're good. Even if we had put on our number line, if this is 0, and that's negative 8, we're saying x has to be greater than negative 8. So any number that is greater than negative 8, so 0 would be fine, negative 1, 2, 3, 4, 5, 6, 7, negative 7.9 would be fine. But it has to be greater than negative 8. It does not include it because there's not an equal sign here. Okay, so that is basically it with two-step inequalities. I hope this helps. Please like and subscribe if you would like to know when there's new content out. And I'm always happy to get a comment in the comment section. If there's something on your GED practice that you're having trouble with, please let me know. I would love to make a video and explain to you how to do it. And I'll try not to make too many mistakes, but if we do, we'll correct them. All right, good luck on your quest to get your GED.